day 6 of the 30-day data science challenge. So I guess this is day 12 on Levin's notebook, but it's day 6 for me. So we're going to go over data preprocessing, and I thought this was useful to go over. So let's see what it has. It's one of the first and most crucial steps, the process in which you make raw data and make it suitable for a machine learning model to increase its accuracy and efficiency. Usually the wrangling and cleaning step takes the longest time in any sort of machine learning flow, and it's one of the most vital steps. So initially you import the libraries. So I imported like two libraries here, numpy as NP, pandas as PD, and then they basically imported pyplot as PLT from matplotlib. So this is a specific library they imported from sklearn imported datasets. When you import datasets, you can import data pretty simply. You can import pandas as PD and then basically read the CSV file with pandas. You can directly load it from Seaborn or sklearn. So they have SNS loading dataset for Iris. Iris is a pretty popular dataset that's out there. It's usually preloaded. And SNS is an alias for Seaborn, so it's just renamed like how we saw matplotlib, pyplot renamed up here. Scikit-learn can also import. So from sklearn import datasets, there's digits, and then these datasets load these digits. So handling missing data values, you can basically handle missing values, incompleteness, or unknown data. And this is one of the biggest issues when building machine learning models. It does impact accuracy. To handle the missing values, you can use the scikit-learn imputer class of sklearn preprocessing. So you basically import this imputer, you impute missing values, and you describe them as NaN. You can also look at the mean of these values and send access, and then it fits these values to something as well. So I'm not really sure what this C to D or A to B is doing, but it's transforming and imputing these values. You'd also encode categorical data. Since the ML model works on math and numbers, it's necessary to encode these categorical variables into numbers. You can use label encoding or one-hot encoding for dummy variable encoding to accomplish this task. From sklearn preprocessing, you can import these two basically libraries, and then the label encoder is basically defined as a function. X of this slicing to 0 fits and transforms this label encoding, and then the one-hot encoder has a similar kind of process for categorical features. And it also does a fit and a transformation. Then it's showing that there's an X value. It also does it for the Y values. Then you can split your data into training and testing data. Training data is used to train the ML model. Feed the algorithm with input data. Given expected output as the algorithm evaluates the data repeatedly to learn and train with the data and its behavior. You can have validation data, which is part of the training process in which the validation data is used into the model and it hasn't been evaluated before. This data also provides the first test against unseen data, which helps in evaluating how well the model makes predictions based on new data and hyperparameter optimization. And you can also have test data, which is basically used after building the ML model. Testing data validates to check if the model makes accurate predictions, as well if it's trained effectively. Then you can split data up. You can use cross-validation, import train test split, and then use xtrain, xtest, ytrain, ytest, and train test split the data. And then the last thing here is basically just feature scaling. It's a technique to standardize the independent variables in the data in a specified range by putting all the variables in the same range and scale so the variables don't dominate each other. It's important because it always converges and gives results faster. You can use normalization, which has min-max scaling as a technique in which values in the data are scaled, so they end up ranging between 0 and 1. And standardization is a technique in which the values are centered around the mean with the unit standard deviation. Last thing here is feature scaling, which you can import the standard scalar library from sklearn preprocessing. It's basically putting in standard scalar and then you're fitting and transforming the xtrain and the xtest data. Thanks for listening.